Hello everybody, welcome to this new Pix4D webinar. My name is Oliver Kung, I'm one of the co-founders of Pix4D, and today's topic is going to be Pix4Dmapper 1.4 with a special focus on precision agriculture and many things related to it. And most of the features of Pix4Dmapper 1.4 are related to this new to enhancements in the precision ag workflows. So this is basically the summary that we're going to cover today. The first point is that we'll go over a quick theory about reflectance, NDVI, how can we actually measure the health of plants remotely. The second point is going to be more talking about workflows. We've done a lot of improvement in the last quite recently in Pix4Dmapper 1.4, and we've learned a lot how to actually better extract data from cameras. So I think it's going to be very interesting to share all what's our experience and that we got from that, and we'll show how we recommend to go from drone to a tractor and how can we use this NDVI data and not just produce NDVIs. And then we'll go into a demo of 1.4 where I'll show from some examples how to use the new features and how can they benefit your existing workflow. As usual, this webinar is recorded, so don't worry, everything will be on our YouTube channel. As you can actually write directly right now, if you watch this webinar live, you can type directly in the webinar box questions, and our support team is going to answer you during the presentation, and I will pick the most relevant questions at the end and answer them in a small Q&A session. All right, so let's get started, and let's go into some theory on actually just quickly understand what are we really doing and why does it work. So the goal of a lot of this precision agriculture and especially remote sensing with drones is to be able to predict a bit earlier the status of a plant, to get an idea of how the plant is behaving, is doing, and somehow we can also have some early signs that will let us know if the plant is actually going to be healthy or unhealthy and then produce more or less corn or whatever the plant is. So that's we are trying. The thing is, it's about physical property of the plants. So if you think about a plant, it looks pretty green when it's healthy, and very likely it's going to look more brownish and going to change color while it's getting stressed or not enough water or whatsoever. And if you look at the physical property of the sun, how this is interacting, the sun is emitting lights in many different wavelengths. As human, we call them colors because our visual human system is based on recognizing some part of all the spectrum of colors that the sun emits. All right, so it looks like, and this is a very easy conclusion we can already arrive, is if a plant is healthy, it's basically absorbing green color, and it's absorbing red and blue color, and it's bouncing back green color. That's why you see that the plant is green. And this is one of the things that the plant is doing, and a healthy plant has this effect. And if you actually look in this graph below, it goes a bit more in detail on what's the physical property of a plant. And this is the response under different wavelengths of the visual spectrum of a healthy plant. And you can see that basically it behaves here quite flat, quite low, then there's a small bump, goes low again, and then goes very high. And the boundary between here and here is the visual spectrum. Actually, it's right from here to here. And if we extend a little bit more the visual spectrum here, we arrive into near infrared. And we see that the plant behaves in a very particular way in the near infrared area. And that means, and that's what people have been trying and successfully trying since quite a while, is if you can also measure the infrared property of a plant, you get actually a very good, more information about how does the biological process behave in it. Okay, that was the lengthy explanation. I'll summarize it in a word. If, and that's basically what's written there below, a happy productive plant is a plant that absorbs a lot of red and blue and reflects a lot of near-infrared energy. And the unhealthy plant is exactly going to behave reverse. And everybody here has already heard of the word NDVI. NDVI is a very buzzword that a lot of people use, but at the root of NDVI, what do we have? We've got actually, it's an index that's measuring the ratio between how low is this part of the spectrum and how high is this part of the spectrum. And you get a number out of that. The number will be very close to 1 if this is indeed very, very low and this one indeed very, very high. And it's going to be more in the range of 0 or even -1 if the opposite happens. So if the ratio, that the difference between this part of the spectrum and this part of the spectrums are very close. And this is what is called NDVI, and it's very interesting because it's related to many physical property of the plant. And this physical property basically are a very, very good indication to let you know if the plant is in a healthy or unhealthy state, even without having to touch it or to do more analysis to it. So, okay, that was quite shortly what's the NDVI and what actually how we can measure stuff from a plant. However, when we take pictures with the drone or on any device of a plant, we are taking a picture, and a picture is not a plant, it's a picture of a plant. And there's some differences, and that's actually what I'm explaining right here. This is the picture of the plant, and the picture of the plant is actually the combination of the sun that basically emits lights, that bounces on the reflectance, which is on the real plant. This is the physical property of the plant, and then get captured by a camera. And this process is actually making an image. So what I was talking about on the previous slide, I was not talking about the image. I was talking about the real reflectance of the plant, and I was talking about this value. However, when you take an image, you actually get this guy on the left and not this guy on the right. And this is what is expressed with this equation. An image is the sensor times the reflectance times the illumination. So the good news is that it's pretty easy to revert. If we actually care, and we do care about the reflectance and not about the image, this is next slide, you basically take the image and you try to remove the effect of the sensor and you try to remove the effect of the sun. And if you do that, you get back to the reflectance. And the reflectance is on what you can compute NDVI and where you can compute more indices and get more information of the plant. So it's just to remind in the general framework that it's not just about the image, it's the image, and it has to be controlled somehow in order to be able to get back the reflectance and then to do the computation on the reflectance. All right. Then to be able to do this to remove the effects of the camera and the illumination from the image to get the reflectance, you need to estimate the amount of sun, and you also need to estimate what's the effect of the camera. So first, let's go into quickly understanding what's the sun. The sun is indeed, most of the time, it's behaving in emitting quite the same amount of wavelengths in each of in the channel of interest. So usually red, blue, green, and infrared. In this, when we have the sun quite at noon with no clouds, no weird atmospheric effects, it's behaving that it gives us about the same amount in each band. However, as soon as you've got cloud coverage, overcast, different time of the day, in early morning or early evening, or different things like that, then the sun is definitely not behaving that nicely linearly, and you're introducing artifacts in the reflectance, and these artifacts will also propagate back in the NDVI and all the computation you do. So that's pretty important to understand and to know that there is a need to model the effect of the sun, and this depends at every single flight you do. And I'll tell just later on how to actually model it and how to and there is now a new feature in Pix4Dmapper 1.4 that allows you to model that. But first, before that, I'll go into also telling the effect of the sensor. The sensor has a big also effect. It's not capturing green, blue, white, and infrared with the same power. It also has some bias where the cameras was not made to do radiometric measures. It was made to do pretty pictures if you use a RGB camera modified one. And if you use a specialized multispectral sensor, usually they have they embedded in it to have a neutral response. And this is basically what we see on the right. Here on the right, you have the three first response are the response of modified RGB camera. So you take a normal camera, you remove the infrared filter, and then you either add a blue filter or you add another type of filter to get two type of responses. And this is what is usually called an infrared camera, and this is what is usually called as a red edge camera. So these are the cameras that are equipping, which are used by SenseFly, and this is the responses that SenseFly has computed for their camera. And what you can see there, that's indeed they do have some responses here, most in the infrared, and here more in the red edge, but they don't do it with the same power, and this has to be taken into account. Another thing to take care of is the last picture is actually a multispectral camera. This is the Multispec 4 from SenseFly, which is, and there's a big difference between these two cameras. This one has much more narrow band, no overlap, and the amount of power is also better regulated. In addition, it's not capturing only red edge or infrared, it's capturing red edge and infrared in one single flight, which allows you to do more computation. So that's just the basic framework. And to know which camera can you use in which settings, we just recently wrote a guide about that that we are going to publish very, very soon. So this is about a 10-page guide which lets you know what are the camera requirements for precision agriculture, and basically how to take care in which steps, which are the important steps to take care on how to get the best results from both a modified camera as well as a camera which is specialized for multispectral, such as a Multispec 4, a MicaSense, a TetraCam, and a few other brands. And that's not the only thing. This is how to transform simple images into reflectance maps, into reflectance images. And then what Pix4Dmapper is building is from this reflectance images, it's building a reflectance map. And for that, it's basically accumulating the different view angles from all the different directions into a single map to produce better results. And you may have seen in the software that there are two things. There's the reflectance map and the automosaic, and they are not the same, and they should not be used for the same purpose. The automosaic that Pix4Dmapper produce is really optimized for aesthetic quality, file size, speed, really beauty, and accuracy, but in geometry. And however, the reflectance map has another goal. There, it's optimized for radiometric accuracy. And this radiometric accuracy, basically the fidelity of using your tool as a measurement device, is the most important. You don't want something pretty. You want something that's a measurement that you can trust the results. And this is one of the big goals of the reflectance map, and we do a few things differently. To really understand the exact difference on how Pix4Dmapper is using your data to generate reflectance map auto mosaic, it's way too long to explain in a webinar. So this is why we have this guide, and that we will publish in the next following days on our website, where it's really explained detail by detail what's the difference and what we take in account. And maybe last point on this different camera, the filter modified standard cameras and the multispectral cameras. As I can see, somebody's asking a question about hyperspectral cameras. Indeed, it's also taking account, it's multispectral and hyperspectral cameras. That's I just put multispectral, but you can also add hyperspectral. It's basically the same behavior. So the first thing that we noticed in the last, by doing all our experiments and doing all the improvements on how to understand how to better manage the colors of the camera, is basically we manage in 1.4 to get enormous improvements in generating NDVI map from normal modified cameras, so filter modified cameras. And one of the key things to do that we understood was how to really use these cameras in terms of very precise measurement cameras. And one of the key of this thing was to actually use raw imagery instead of the JPEG images that were produced from the camera. And in the guide I was talking about, there's a whole, it explains all what needs to be to be modeled inside of the after taking the raw, how to correctly convert it into a TIFF, and this TIFF, how to make them perfectly compatible with Pix4Dmapper. And if you follow this guide, the results you obtain are really, really incredibly good, and quite a magnitude better than if you were using the JPEG images straight from the camera to produce an NDVI. So anybody using filter modified standard cameras, I would really strongly suggest to follow the guide. Now, on another hand, we are working with a few dedicated manufacturers, both camera and UAV manufacturers, to make it as seamless as possible. So the good news is for people using SenseFly devices. This is something that we worked together with SenseFly very closely to make sure that it's a seamless experience for the user. And as a user, you don't have to do anything to do this conversion. This is something that is integrated in the workflow of the drone and other software that comes with it. So in that case, if you're a SenseFly customer, you don't need to follow the guide. If you're not a SenseFly customer and you still want to use your RGB camera, then two things: either follow the guide or strongly suggest to the manufacturer that sold you the camera and the drone to get in touch with Pix4D, such as we can make sure that we collaborate to make a workflow that's as smooth as possible. Now for multispectral camera, the big difference is usually, well, instead of having 3 bands, you have usually more bands, and that allows you to capture, like, for example, near and red edge at the same time. For hyperspectral camera, then you can capture actually even more finely the wavelengths, and you can start doing much more interesting computation on them. The big difference also with the filter modified camera is that they are usually narrow bands, the multispectral camera, and not broadband, and that also changes a little bit the list of indices you can compute from them. And now the big thing that makes it much easier to use usually is the fact that this multispectral camera, so like Multispec 4, like MicaSense or TetraCam, the manufacturer usually takes care of making sure that it's radiometric, of the radiometric fidelity. So you don't have to follow that much the guide. Many steps you can be skipped because they've already been taken care of by the manufacturers. But still, there's a few steps which I'm going to talk about right later that still needs to be done. So that was a bit more an understanding. The first part was really about an understanding of why NDVI works, what are we trying to measure, and what is important. So to take care of this thing. And I'm not going to try too much to talk in this webinar about how to really take care of your camera. For that, it's it makes much more sense to go into reading the guide that's going to be published in a few days. However, something I really like to talk about is in a sense going further than just producing NDVI, because we've been able to produce quite NDVI for a while, but what do you do with them? And we've been thinking a lot on this question, and that's what we also have been trying to change a lot, the 1.4 processing to actually make it better. And this is basically the workflow that we propose. Fly once with the infrared camera, and before the flight, use a calibration target. And the calibration target is exactly the tool that you will need to use to be able to compensate the effect of the sensor and the effect of the sun. So this, starting to use a calibration target, a radiometric calibration target before each flight, is making a very, very big improvement in terms of quality of results, in terms of radiometric fidelity. And Pix4Dmapper now has an interface to use this calibration target and take them in account for computation. So you fly once on your field. The next thing you do is you start computing NDVI with the rapid workflow. And now we have a whole automated workflow where you basically just have to set it correctly. You press on a button, and it goes automatically up to generating and color mapping NDVI by itself. So and using the rapid check, it makes it really, really fast. And there you get a low resolution, but you already get an NDVI map. And this NDVI map can easily be loaded, for example, on a smartphone. And once you load it on your smartphone, you can basically go in the field and do scouting, which is basically ground inspection at the places where you have low and high NDVI value. So there are possibilities to skip this step and not to do any scouting, but this is not something we recommend. NDVI give you a lot of information, but they don't usually give you absolute information, and they don't tell you what's happening below the plant or if there are diseases happening or anything like that. So we really recommend to use the first part of the processing really as a way to optimize the scouting time. And you still have specialists that go on the field, check what's happening, but instead of checking randomly where they need to go, they actually have a map that they see on their phone and that is already geolocated, that lets them guide where they should go, and not just randomly, but there are really places where it's red and where it's green, that they should actually follow this place to check what's happening there. Once it's done and you've done your measurements, you go back in the office, and there you can do, instead of using a rapid processing, you can use a full processing. And not only full processing, there you can also take in account the measurement that you did using your calibration targets, and you can draw the boundary of your fields in the index calculator to not be biased by data which is not the fields, basically the roads. So you can draw to make sure that you don't put the roads and the grass inside of your computation. Then what you do is basically this. So once this is done, it automatically creates different classes of different NDVI values. So it groups the NDVI value into different regions and in different classes. And you basically can start matching visually you have on one window the measurement you did on the ground, and on the other window you have these different classes at which are displayed on the map. And this is basically when you start to take decision and create prescription maps. So taking decision is usually the place where you have very, very low NDVI value. If you checked by scouting that actually it's not even low NDVI value, it's that the plant is really dead, you don't want to start putting fertilizer there. You actually want to save fertilizer, because putting fertilizer on a dead plant is not going to make it more happy. You actually want to save your fertilizer for plants which are still that are stressed but not beyond recovery. So this is really this requires indeed some agronomy knowledge, but thanks to the match of the visual observation and your knowledge of the field and the match with the NDVI map, you can start taking quite easily this decision of, for example, the low NDVI value that's where it's written, where you did the observation that the plants were pretty dead, then you actually want to go further and to do the one that are very heavily stressed. This one, very likely you want to add a lot of fertilizer. And the one that are very not very stressed, then maybe you also want to save some fertilizer, and you don't need to you can save fertilizer costs by not putting too much of them. And basically, this is what I'm going to show in the software later on, how you do that. And this is what allows you to generate within Pix4Dmapper a prescription map. And this prescription map, you can export it, and you can export it as a shapefile. And this shapefile is a shapefile that can directly be loaded in the console of your tractor, if your tractor is equipped with GPS and different in a rate application machine. Then you can use this prescription map and directly load it. We've done all the tests to check that it's compatible. And by loading it in the tractor, you can start doing directly application of the decision you took previously. It's also possible to load it into traditional farming software like AgLeader or FarmWorks. And this file is a very small file that can be easily transported and shared and open in many different things to do advanced editing before loading in the tractor. But basically there you've got from flying to action in the field, a whole things that can be done. So just in the question that were asked during this last slide is, does it work with other things that NDVI? Yes, of course. NDVI is just one of the index you can compute. It's the one usually if you use a modified camera like a Canon where the filter were changed. This is usually the most reliable index that we advise to compute from. However, depending on your camera, your sensors, if you have a better multispectral camera and so on, then any type of indices can be computed. We have basically a small place where you can edit the formula. And as a small recommendation for people using modified camera, I would say that if you have a modified camera that reads mostly the infrared, then NDVI is basically the formula you want to use. If you have a camera that reads mostly the red edge part of the spectrum, then chlorophyll index is another index you actually want to compute, which makes more sense. And generally, it's accepted that the NDVI is mostly about to know about the structure of the plants. So basically, is the plant dead or not dead? And red edge, meaning the chlorophyll index, is more appropriate when you want to know how much stressed is the plant. So before fertilizing a fertilizer application, it sounds more reasonable to use a red edge type of index, and just to know if the plants are not having diseases or disease started to spread or not enough water and so on, there the NDVI index is usually more appropriated. Okay, got a question about thermal imagery. So thermal imagery does work with Pix4Dmapper, and we've got some really nice example of using the index calculator also for thermal imagery. However, I'll just put a small note there, is that for thermal imagery to work, the way the images are taken has to be very well taken care of. And we are aware only of a few different type of manufacturers that are able to produce a drone that does the flight plan and the camera integration, the thermal camera integration, that are good enough that can be used for doing mapping. And SenseFly is one of them that's proposed a thermal camera that we worked very closely with them to make sure that that the whole thing is really well integrated, and you can generate thermal maps from them. Again, if your favorite manufacturers of drone is not providing that, then feel free to put pressure on them to contact us and work more closely with us on making this happen. All right, so let's go on. Now for an example of the workflow I just described it there. So this is a data set. Again, this was taken. This was taken with a SenseFly with an infrared camera. So it's with the near infrared camera that they are selling, which is basically a normal Canon camera with a modified filter. In addition of just being this modified camera, it goes through the new workflow of the post processing software of SenseFly that allows to convert correctly the raw images into very good imagery that can be used that doesn't distort the radiometric values. So as input for this data set, basically the images are images that are not where the radiometric is not distorted, and that makes a huge improvement in the quality of the results. So let's check here. We have now added in Pix4Dmapper 1.4 a new tab called Index Calculator, and in this tab you can basically say in advance, without having to open the index calculator, what do you want to compute, and you can basically tell the software to in advance use produce a reflectance map, use an index and compute the index, and generate already even the contour maps of the different segmenting in different classes and color mapping it and giving and separating it in different classes. In addition to that, there's this tool which I talked about, which is the radiometric calibration tool. And this tool basically, if you click on calibrate, it allows you to open an image. It should be an image of a calibration target, a radiometric calibration target with known reflectance value, something like could be something like the size of a piece of A4 of paper, but the material that is done, the material of this radiometric calibration target should be something where you know the reflectance value. This is usually available in photographic shops. So if you don't know what you're talking about, go to your closest photographic shop and ask them for radiometric calibration targets. They will give you one, and basically you need to take a picture of it before each flight. Once you do it, you basically annotate here you can create a polygon, and this polygon is just to make sure that you select only the interesting part of the calibration targets. Then the guy who sold you the calibration targets usually gave you also, or you've got to ask to him to give you also the albedo value. So the amount of reflectance for each of band of interest that you are looking for. And if it's kind of a grayish thing, it could be something like 0.5, 0.5, 0.5, but very likely you need to ask the manufacturers of this radiometric calibration target which are this value, and this manufacturer will give it to you. Okay, once it's done, basically, if you have these calibration targets and you click OK, it's going to use this to both estimate the bias of the illumination, so the sun, and the bias of the sensor of the camera, and this will improve a lot the reliability of your results. So the NDVI values, for example, that you'll get from it will be much more reliable than if you don't do that. All right, then when I was talking about the rapid check, what I would recommend for people to do is to have the initial processing and to here check rapid check. For the rapid check, you don't need to do point cloud densification. So I would recommend to disable point cloud densification step. And then the third step, you can keep it, but you've got to go in the option and disable everything which is related to DSM and to automosaic, so you don't waste computation time. Instead of it, you go to index calculator and you make sure that the GeoTIFF is checked in. And here by default, the value is 50 centimeter per pixel, which makes the processing much faster and still provides you enough data to start doing the scouting on the field. If you press OK and then you start the computation, you will end up with a file which basically is in this folder, in your project folder for index, and there you will have under indices and NDVI, there will be there is actually a JPEG image that has been produced, which is up. Actually, I need. Where's this guy? Ah, wrong. Sorry, wrong tab. So in the folder I was showing, of course, that's probably the demo effect. There should have been, actually it's right there, I see it now. There it is. You've got a color mapped version of the NDVI from red to green, and this one is basically the one that you can go load on your phone. It's georeferenced, so there's all the files to georeference it. And by loading it on the phone, then you can go on the field and go check which are the hotspots and the low spots. So basically, in this field, you would probably need to go check what's happening here. You will also need to check what's happening here, and at different parts. And this guides you a bit to get. It's really recommended to go check a few of the really red parts and a few of the really green parts, and annotate that on the map on your phone. And when you come back to the office, basically you can load this data back in your computer. So, okay. Where am I? So I went in the options. And I've got too many files opened. So let's go back to this one. So here I'm starting to generate the let me open back the software. So this is going to be easier. Sorry for the inconvenience. I'm loading too many projects at the same time. Let's take this one. So a question asks, how can you load this map on the phone using GPS? What app? So it depends first if you have an Android or iPhone, and there are many. This map is actually compatible with any GIS iPhone app. So Quantum GIS has an iPhone app, and there are many other software that's scouting software. Most of the scouting software have also this type of capability of loading this map. So any GIS software basically can do it, both on Android and on iPhone. Okay, I'm almost back in business. Index calculator. All right, there I am. So here's the new 1.4 interface, and we simplified and removed and streamlined a lot of what's happening on the right. So by default, we compute the reflectance map at 50 centimeter per centimeter, 50 centimeter per pixel. This is usually more than enough to get reliable classification of your field in different areas. However, there's nothing that restricts you to go to full resolution like 2 centimeter per pixel. But usually, we really recommend to stay at something a bit higher that provides usually better quality data at 50 centimeter per pixel and also makes it much faster. Then the next step is that you can start generating and this is one of the new possibilities also right now. You can do the analysis instead of doing for the whole field, you can actually do it for different regions. In this particular example, this is a corn field, but it's not the same corn in the whole field. Actually, you have one part of the field which is one type of variety of corn that takes about 90 days to mature, and the other part of the field is corn that takes 110 days to mature. And it doesn't make any sense to make the same amount of the same analysis at the same time on both fields. You actually need to separate the different fields to do the analysis separately. It provides you much better actually classification and also results. So the software basically allows you to add different regions. So let's call the first one corn 1 and the other one corn 2. And now in corn, let's select corn 1 and you can draw an area that basically encompasses this region. And then you go in corn 2 and you draw again for the other part of the field the second area. And then you can switch here from corn 1 to corn 2 area. So let's do the analysis first for corn 1. The second thing you can do is select which type of index. So I said we built in the NDVI one, but you can basically access to the index formula, and there you can enter any type of index, like a chlorophyll index. And there are several dozens of indices that make total sense to compute with infrared cameras, and there are lists available on internet and on our support sites on which one we recommend to use in which situation and depending on which camera you have. So here's the list. Here's the way you can choose and edit and add more formulas. And by default, then you need to generate the index map for this field. So basically, you click on generate, and it's a very fast process. And there you just computed the different areas for the different places. Maybe I can use this one too. Okay, so let's take the whole area at the same time now. What the software is basically doing is by default, it's classifying your data into different regions. And here you are. So by default, we pre-select 5 different classes. And why 5 classes is that usually this makes sense to separate your field in 5 different areas. And also the application rate of your tractor usually does not permit to do much more than 5 different type of applications at different rates. So it's something that also makes sense with the hardware that can be used to then further do the processing, the application on the terrain. By default, it uses an algorithm which is called equal area to compute the spacing between the different classes. And this equal area algorithm is basically trying to separate the NDVI value in such a way that each of the classes take the same amount of space on the terrain. This is a very normal type of algorithm to use in this case, and usually provides a very good segmentation of the NDVI value in something meaningful. You can, in case that there is you need to do further analysis, you can basically override this the algorithm by adding a minimum and a maximum value. This is pretty useful if you have, for example, artifacts or road or things that you need too much soil. The soil is going to be, if you have a orchard like you do in something where vegetation is not everywhere the same, but you've got a lot of soil data in your pictures, then one way to remove the soil is to put a threshold on the minimum value. Then this is the step where I was talking that you could basically, where we recommend to check between the data that you measured from the ground on a separate window and the data that is here on the as mapped as an NDVI value. And by measuring basically it allows you to map what are the different colors related to what type of class. So in this one, sorry for the discrepancy of colors. I'm using a development version where we actually allow further to change the color of the classes, and this is not possible in the 1.4 currently. This will come in 1.5, but you will have actually the map of the green to red, which is in the index map, which reflects also here in this little class box. And by correlating visually, if you see that this red is related to an area where the plants are dead, then basically you can say that the red value is equal to dead plants. So you can add this as a comment here, and you can tell that the rate that your tractor should apply is very likely should be 0 because you don't want any fertilizer to be applied there. However, a value which is a bit higher than that, and you checked with by the scouting and by making sure that this color corresponds to a place where you have scouted and done an observation that heavily stressed plants, so it's worth to put it there as a comment. And there, very likely, you want to apply a lot of fertilizer. As you can see, there is no units there. The units is usually something that the tractor is going to ask you. So here we just let you put a number there. And the units, you have to keep it in your head and make sure that when you transfer it to your tractor, you use the same units. And very likely you'll end up with something like that, where you'll the healthier the plant, the less amount of fertilizer you want to apply. So heavily stressed, and this one low stress. And then by clicking on the export button, you basically generate this type of map. So you generate a vector map. So this is a shapefile, and this shapefile is the shapefile that can be directly imported in tractors. So as you can see, it basically does regions, all right? And each of these regions have as a comment in it the amount of rate you want to apply. And if you take this shapefile and you import it in your console tractor, it's going to load it and then going to ask you which is the column that is the rate. And that's where you select in your tractor console the rate for this particular value. And you can directly start spraying with the different rates. And also normally the console will also ask you, as I just said before, what is the unit that of the rate you wanted to apply. And for this particular map that you see on the the example I was using right there for this map, I used actually we did during all of last year experiments where we flew multiple times over this field, and this is something like 2 or 3 months after that the plants have been starting growing. So it's on the second month of growth season. So that was done in June, end of June. And this is basically after computing automatically the NDVI, having the radiometric calibration, and doing exactly the same process that I just did. So putting the field boundaries and putting the prescription as was observed on the ground. This is basically the map we obtain. And to the very interesting question, how much does it relate to the real truth, which is on the terrain? Well, in that example, this was a last year data set, and at the end of the year, at the end of the growth season, when the tractor was used to get the yield and to check how much growth there was done at each of this area, we actually also monitored the yield of this particular data sets. And this is what you have. This is what now you see. This is a yield map that was produced by the tractor that was cutting the corn and to store it. And it was able to compute by cutting the corn how much corn was actually available in the different places. You can see some areas had very little poor corn and some were good. And when you look at that, when you make the difference with the map that was computed by automatically using the index calculator in Pix4Dmapper, basically you can see that indeed there is a very, very strong correlation. And if you would have used this map as a prescription map, you could have improved a lot the productivity of your field, as well as saving fertilizer where the plants were anyway already it was already too late to save them. For some reason, some places there was not, the seeds were not planted correctly, and some places there was some disease happening during the year. This is, of course, more single experiments, and it cannot be taken as a global truth. Each fields are different, each camera are different, and each recommendation are different. And there's still a need for agronomy knowledge. But if you follow the workflow that we basically display here in this particular slide, there is already a quite the data that you'll compute and the way you can apply it is going to be already very, very close to something that can for sure improve both your productivity and the amount of fertilizer you need to apply. All right, so this is basically most of the presentation I wanted to do in an hour. Now I'm going to take a few questions from, so you can type additional questions in the chat box, and I also will answer a few of them live right now. So, okay, I got a question about what's the maximum amount of region that can be done in Pix4Dmapper. Basically, I'm going to answer this question too. There's no minimum amount of regions. So these regions you can draw 100 of them. The next feature that's going to come in Pix4Dmapper 1.5 is the ability to import and export this region. So for now, you'll have to draw them one by one. So if you have 100 regions, you'll have to right now draw 100 little plots. So it may be not very comfortable, but it's possible still to do it. In the next version of Pix4Dmapper, there will be a way to import and export the field boundary, so you don't have to draw them every time, and you can import from existing shapefiles. Now another thing is also number of classes. How many classes can the software compute? Well, you can put as many classes. There's no minimum number of classes in which it's segmented. So you can basically write 255 classes, and this will segment in tons of different little areas. So in different classes. So there's no minimum and maximum number of classes that you can input there. Okay, got the question about, is the possibility to reuse the same field? There, right now not. This is something we're working on. So in the next update of Pix4Dmapper, there will be the possibility to import and export the regions. Will the calibration procedure using targets explain more details in the online support? Yes. So I didn't go in very quick details about the procedure here. I can maybe just repeat it. Basically, before the flight, take a picture of your calibration targets, and then in the tool, in the option here, you select calibrate, you open the file, you just draw a polygon around the file, you set the right numbers depending on the physical property of the target, which are the one which is given by the manufacturer of the calibration targets that you will use, and then you press OK, and then it's going to be used automatically in the workflow. And in support.pix4d.com, we just updated it recently, where we added all the explanation for all of the different parts of the software, how this is used. Okay, somebody asking about the algorithm we have to do classification. Indeed, right now we have equal area. We also have equal spacing, and we just finished developing natural breaks, which is also called Jenks, and this one will be available in the next version, so Pix4Dmapper 1.5. So right now we have these two different classification methods, and very soon there will be natural breaks also coming on top of that. Is the calibration target must be photographed under the same illumination condition than during the flight? Yes, the answer is yes. The goal of this calibration targets is to estimate the bias both of the sun and of the sensor. So you need to take them under the same condition as during the flights. That's why you need to do this calibration at every single flight. For example, if you wanted to minimize if you wanted to use a tool so you don't have to use this calibration target, it's possible. And it's basically an upward-looking sensor that does this irradiation measurements. Unfortunately, most of the manufacturers that produce this upward-looking sensors are only checking at the amount of irradiation. They are not checking at the difference between each of the bands of what's the wavelengths between the different bands. So for now, basically, it means that for almost any camera, you've got to use radiometric calibration targets. However, we're quite also aware that some manufacturers are working on adding sensors that are also going to capture the irradiation of the sun at different wavelengths. And once this type of additional tool will be available, you won't need to use a calibration target anymore. This sensor will normally be good enough, such as you can not have to use the calibration target and still get very good results. Okay. A few more questions. Can the calibration targets from the multispec 4C can it be used with the 110 infrared camera? So I presume that this question was asked from a SenseFly existing customer. The answer is yes. This calibration target is like any other calibration target and can be used to do the radiometric calibration of any of other camera, including the modified Canon camera that are sold by SenseFly. So yes, this can be used as a target, and we do provide either on SenseFly on our Pix4D website the values that you've got to put in this area. It's not 0.5, it's I think 0.6, 0.5, and 0.4, something like that. The exact values are available on the support website or directly when asking at support.pix4D or at sensefly.com. What is the minimum overlap during the flight you recommend for flying the Canon, the modified camera? That's a very interesting question, and then it actually, I can there expand a little bit. That I showed a bit the easy way of agriculture, but in reality things are even more complex. I didn't talk in this presentation. I didn't talk about some additional effects which are also present and that may do artifacts and some reduce the quality of your data. One of them is sun reflection. So basically, when you've got the sun, when you're doing agriculture and you take pictures of from the drone of the field, you have some areas which look more bright than some other area, and sometimes this is due to sun reflection. Basically, the field acting a bit like a mirror, and you've got the sun reflecting more in a direction than the other. One way to reduce this type of effect is to increase the overlap. So usually the more overlap you have, the better quality your data will be in terms of radiometry. However, it's also to be understood that, of course, the more overlap means also the slower the processing going to be. So if you start seeing that you have some strange artifacts, like some areas which looks a bit brighter and you cannot explain them in the reflectance map, basically that's one way to improve a lot the results are to increase the overlap and to go more into something like 80% of overlap, so that making sure that every pixel of the reflectance map is seen by 16 to 20 images. This will, when we are computing in the reflectance map the value of a single pixel, we are actually taking carefully the different directions, and we are weighting them differently depending on many factors, including how close the pixel is from the center of the camera, and also what is the angle of incidence and of the camera with respect to the plans. And by taking this in account and by taking multiple measurements in account, we're able to discount a bit for strange additional reflection effects. And so short answer, the more overlap you can do, usually the better quality your reflectance map is going to be in terms of radiometric quality. However, if you, depending on the conditions, in some situation with even normal overlap of 60–70%, you will already you won't get any artifacts, and the data will be of good quality. So this depends on the plans you basically are trying to map. Okay, a question about calibration when flying under scattered clouding. So the clouds are not an issue by themselves, as long as you can measure the effects of the illumination on the different part of the spectrum. And basically, when you're doing it under scattered clouding, the most important is to use the calibration target. The radiometric calibration target is going to neglect to compensate for the effects of the lightning that's done by the scattered clouds. Now I'll extend a little bit the question about, okay, sure, but what if the clouds are moving while taking the pictures? Indeed, that's a totally different problem. And there is no really right solution in any case to do that. So when you have clouds which are moving and changing a lot the brightness, and not just the brightness, but also the color temperature of different parts while you're doing the data sets, right now the data will be of much lower quality. And this is because you're measuring things under varying conditions. There are a few ways to compensate for this thing. One of the first way is to use one of these sensors that is looking upward, that measure the amount of light. And by measuring the amount of light during the flight, you're able to measure how the light is changing. And by measuring how the light is changing, you're able to compensate for it. One of the cameras which have this system and we have heavily tested and works nicely in Pix4Dmapper is the multispec 4 from Sensefly. So in this camera is writing the data inside of the images about the amount of light, and Pix4Dmapper is able to read this value and to compensate correctly for the different amount of lights. So this is basically one of the way, but for that you need specific cameras with specific sensors to make this work. Okay, what about the capture app for NER cameras? So the capture app that we created for the iPhone and Android is right now only compatible with the Phantom 2 Vision that basically has a camera in it that's not really supposed to be changed. So very, very soon, however, we are extending the list of drones that are compatible with our capture app, and for sure you'll be able also to use our capture app to generate NDVI maps as soon as you can actually put NER camera on the drones which will be compatible. Okay, very interesting question. Has any work been done on field sensing prior to planting to determine soil preparation requirements? Yes, there's been done work, but not by Pix4D. This work is mostly either academic work that you can find in papers online about this type of things, but not exactly related to remote sensing. And basically, this is more general agronomy knowledge that is still required to get the best out of these NDVI maps and of this remote sensing. So with Pix4D, you basically can right now generalize areas of similar health status, but we are not pretending that it's possible to compute automatically how you should prepare your soil, how you should prepare how much fertilizer you need to put, and so on, because it depends on way too many factors. It depends on indeed, as in this question, the soil. It depends on legislation. It depends on many different factors that basically we do not believe that you can use an automated technique in every situation. So for most of the cases, we believe that you need a tool that you can use and that you can compare with ground measurements. And with these ground measurements, you can start taking decisions that you can trust. And this is basically the tool that we have built in Pix4Dmapper 1.4. Okay, let's look at further questions. All right. Okay, question about stitching. What is the minimum amount of pixel damage I can have? For example, blah, blah, blah. I'm afraid that stitching artifacts could be maybe 10% of an image slice of a research plot, if the unlikely plot has several stitching seams running over it. So with the reflectance map, we do not do seams. We do not do traditional stitching in a sense that we use one image and another image and that we put a seam between them. In the reflectance map, every resulting pixels are computed by integrating as many cameras, as I said before, taking into account the angle of incidence and also where it is in the image. And by doing that, we basically avoid having seams, strong seams. However, in the reflectance map, you can see seams. This is basically an indication that the camera was not properly set up. If you can see seams, it means that the camera was sensing a different type of rate, a different part of the terrain. And that can be explained either because lighting conditions have changed, and in that case, you can do nothing unless you have a light sensor that does the measurements, or that basically means that the sensor is not correctly set up. And for that, I really would recommend to read the guide, which we're going to publish in a few days, on how to correctly set up your camera to make sure that you can use it as a proper measurement tool. Some people would tell us that, yes, but you should be able to compensate this value. However, we do not believe in compensation for reflectance map based on heuristics. For a reflectance map, we want to make sure that the measurements are perfectly reflecting the reality, and we are not introducing some type of interpolation or bad type of estimation of trying to adjust the brightness between the different pixels. The reason is, if it's not done properly, we are basically, if you do this type of techniques, you have a huge likelihood of introducing wrong data, fake data, and that's something we don't believe in for doing reflectance map. We think it's not it's going to be hard to detect where this wrong data has been computed, and maybe not on the first map, but after a while, you may realize that your data is definitely not the same as reality. And if you start, and as it has real life implication, as the amount of fertilizer is going to be applied, we really believe that the answer is much more into making sure that the capture, the sensor, the camera is well prepared, And if this is the case, then we don't need to provide artificial corrections. And if we don't and if the data looks good without artificial corrections, it basically means that it's really reliable. So okay, I a bit extended the original question. Can I, after a preliminary stitch, go in and define no-go zones for stitching or approved corridors? Yes. So once you've done there, you can always go back in this region editor and add additional regions. Like for example, if you wanted to add just this corridor, and then it would compute the NDVI and the classes just in that specific corridor. If you want to reduce also the amount of reflectance computation you do, so you don't want to compute the reflectance map for all these different areas, then you go in the map view, and here you define an area which basically is smaller than what you're looking for. And this one will also make sure that we don't compute values which you are not interested with. All right, so I think most of the questions have been, many questions have been answered, some have not, but the support team is normally still going to answer all of these questions. If not, you're always free to write mails to support@pix4D.com. We'll be very happy to answer you. With all of that, it's been 1 hour 15, so thank you very, very much for attending this webinar and during the whole course of this webinar and to ask very interesting questions. Thank you very much for this, and have a great day, and I hope you'll do lots of mapping and lots of farming, precision agriculture mapping with Pix4Dmapper 1.4. And as always, feel free to send feedbacks, suggestions, and also results of your maps to Pix4D. Thank you very much for watching this webinar. I hope you'll be there for the next one, which will be in 2 weeks, which will be open question and answer webinar, where there will be no exact topic, but we'll be talking about what's the future of the new release. If you have feature suggestions, if you want to tell us some detailed things, we'll also show some cool data set we've been processing in the last weeks. So it's going to be more an open discussion during half an hour, and then we'll have another thematic webinar in a month, and the new theme will be posted very soon. And that's basically also for the new webinars how it's going to be structured. So every 2 weeks there will be a webinar with a theme, and every month there's a webinar with a theme, and every month with 2 weeks delay there will be a webinar with more open questions where you can just attend and check the nice projects that we have done, what's the future of Pix4D, what's the future of Pix4Dmapper, and ask any type of question. All right, thank you very, very much for attending. Have a great day, and hope to see you for next one. Goodbye.